In this example, we will look at a function represented graphically. Assuming the base temperature setting for the thermostat in a house is 65 degrees Fahrenheit, we will let g of x be the temperature in Stan's house, measured in the number of degrees above 65 degrees Fahrenheit, x hours after midnight on January 1st, 2016. We are given the graph below, and we will answer the following using this graph. In part A, we need to find and interpret g of 2. We need to recognize these are two separate questions. The first question is to find, and the second part is to interpret. So in terms of finding g of 2, we need to recognize that the 2 given in the function notation g of 2 is an x value. So if we go to the x value of 2 and look down to the graph and find the point on the graph that has an x value of 2, we can find the y value. So we can state g of 2 equals -3. Now with that being said, we need to recognize what an x value of 2 means. An x value is the number of hours after midnight on January 1st, 2016. So an x value of 2 means 2 hours after midnight. That means 2 a.m. on that particular date. The output values from the function, or the y values from the function, represent the temperature measured as the number of degrees above 65 degrees Fahrenheit. Well, since we have -3 degrees above 65 degrees Fahrenheit, that's telling us we're actually 3 degrees below 65 degrees Fahrenheit. So we're talking about 62 degrees Fahrenheit. So to interpret this, we simply need to state what the x and the y values mean in context and as a sentence. So an interpretation of this can be, at 2 a.m. on January 1st, 2016, the temperature in Stan's house was 62 degrees Fahrenheit. In part B, we need to solve and interpret g of x equals 0. Again, we need to recognize this is two separate questions. The first question is to solve the equation. The second is to interpret what that solution means in context. So we're trying to first solve the equation g of x equals 0. Since x is still in the equation, we don't know the x value. If we don't know the x value but we're given a number, that means that the 0 we are given in g of x equals 0 must be a y value. So we will go to a y value of 0 on the graph, and we will find any point on that graph that has a y value of 0. The solutions to this equation will be the x-coordinates of any point on this graph that have a y-coordinate of 0. We can see from the graph that there are two such points. One point has an x-coordinate of 4.5. The other point has an x-coordinate of 9.5. So to solve this equation, I will simply state this as a solution set. The solution set for this equation is 4.5, 9.5. In the interpretation, we need to now interpret what a y value of 0 means and what x values of 4.5 and 9.5 represent. So beginning with the y value, since the function output values, or the y values, are the temperatures measured in degrees above 65 degrees Fahrenheit, and we're talking about 0 degrees above 65 degrees Fahrenheit, we're talking about a temperature of 65 degrees Fahrenheit. Again, the x values represent the hours after midnight, so 4.5 hours after midnight would mean 4:30 a.m., and 9.5 hours after midnight would represent 9:30 a.m. So to interpret this, we could say the temperature was 65 degrees Fahrenheit at 4:30 a.m. and 9:30 a.m. on January 1st, 2016. In part C, we need to state the domain and explain what it means in context. Remembering that the domain is the set of all inputs, or x values, I can see that this graph, in terms of the x values, goes from 0 all the way over to 12. So that tells us, in relation to the x-axis, or the x values, the domain is 0 to 12. Because this domain includes every x value from 0 to 12, we will write it as an interval. So it is the interval from 0 to 12, including both 0 and 12. So what this domain means in context is that the graph tells us the temperature in Stan's house from midnight to noon on January 1st, 2016. In part D, we need to state the range and explain what it means in context. So the range is the set of all the y values. So now I'm looking vertically to see how low and how high this graph goes. I can see the graph tops out at a y value of 4, and I can see that it goes down at a minimum to a y value of -3. So the range will be from -3 up to 4. Again, because the range includes everything from -3 up to 4, we need to write this as an interval. So bracket -3, 4, bracket. The range is describing all the possible outputs, y values, or in this case, temperatures in Stan's house. A y value of -3 means 3 degrees below 65 degrees Fahrenheit, which is another way to say 62 degrees Fahrenheit. A y value of 4 means 4 degrees above 65 degrees Fahrenheit, which means 69 degrees Fahrenheit. So to put this in context, we are being told that the temperature in Stan's house between midnight and noon on this particular day only fluctuate between 62 and 69 degrees Fahrenheit. So the temperature in Stan's house is always between 62 and 69 degrees Fahrenheit.